Welcome to the deep dive. Okay, imagine a network so secure it uses the laws of physics themselves to protect data. Sounds wild, right? Well, today we're diving into some really fascinating sources about Japan's major breakthrough. They've actually built a functional quantum internet test network, our mission, to unpack what this really is and, why it's actually a pretty big deal for you.
It really is. And it's interesting because that phrase quantum internet, it makes you think of like this global thing, right? Instantaneous quantum connections everywhere.
Yeah, exactly. Sci-fi stuff.
Right. But what Japan has actually launched, specifically in the Tokyo-Chiba corridor, is something, well, maybe less broad, but incredibly important. It's a functioning test network.
Okay, a test network. So foundational.
Very foundational. Think of it as a crucial first step. It's focused specifically on quantum communication and security, not, the full internet replacement yet.
Gotcha. So we're not talking about quantum computers zipping emails around faster. It's more about the security aspect.
Precisely. The security is the key thing here. This network right now is being used for things that need extreme security.
Like what?
Well, think secure video calls, really sensitive banking transactions, that kind of critical application.
And how does it do that? What's the quantum part?
Okay, so it works by sending entangled photons through standard fiber optic cables, actually.
Entangled photons?
Yeah, it's a quantum physics thing. But the practical upshot is if someone tries to eavesdrop, tries to look at these photons to steal the key, the very act of looking changes them. It collapses the quantum state. And that instantly alerts both the sender and receiver that something's wrong.
Whoa.
So it's not just hard to hack like current encryption, which relies on mathematical difficulty.
Right.
It's fundamentally physically impossible to intercept the key without being detected. That's often called QKD, quantum key distribution.
Privacy. By physics. That's kind of mind-blowing.
It is.
And this isn't just a lab concept. It's running now in Tokyo-Chiba.
Exactly. It's a tangible milestone, not just theory anymore.
So why is this specific network, this test bed, why should you, our listener, really pay attention?
Well, it points directly to the future of cybersecurity, doesn't it? I mean, we all know conventional computers are getting more powerful.
Yeah, the whole quantum computers breaking current encryption fear.
Right. And while that's maybe a bit down the road for everything, the threat is real. Quantum encryption, like this QKD, offers security based on physics, not just complex math problems. It's, well, potentially invulnerable to those future computational attacks.
So this Japanese network is like Exhibit A working proof of concept.
A very practical working demonstration of that potential, yeah. It's a really significant step towards a world where, our most private data, our financial transactions, could be protected by these fundamental laws.
And I noticed it's a collaboration. It's Japan's National Tech Institute, NICT, but also private companies like SoftBank and LQUOM.
Yes, that's also really important. It shows this isn't just a government science project.
Right.
It's a serious concerted push involving both the public and private sectors. They see this as critical infrastructure for the future.
So a national strategy almost.
Absolutely. They're aiming for a nationwide quantum encrypted network by, I believe, 2030. It's part of a bigger picture securing Japan's digital future, ensuring data sovereignty, that sort of thing.
Okay, let's bring it back home. What's the main takeaway here for you listening? Japan's quantum test network, maybe not globally yet, but it's a massive step forward, right?
Giant leap, I'd say.
For secure communications. It's real quantum physics applied right now, protecting things like banking in that Tokyo corridor. It changes the game.
It really does. And while, the full national quantum network is still being built out, planned alongside other quantum tech developments through 2030, this functional network is the proof. It shows how countries are actively building the foundations for, well, a fundamentally more secure digital world. It signals a shift.
So this deep dive really highlights how these cutting-edge things today are, genuinely setting the stage for how we'll interact online tomorrow. Makes you think, doesn't it? If our security can be based on physics itself. What else? What other everyday things could quantum tech transform? Maybe sooner than we think. Definitely something to mull over. Until our next deep dive.